question addresses whether a main breaker is necessary when dealing with a 240-volt receptacle. Based on the information provided, the interpretation is that a main breaker may not be required in this particular scenario because the 240-volt receptacle itself functions as one of the contacts within the circuit. To understand this, we need to delve into how electrical circuits and breakers function. Firstly, consider the basic principles of electrical circuits. An electrical circuit requires a complete path for current to flow. This path typically includes a power source, a conductor to carry the current, a load that consumes the power, and a return path. In a standard 120-volt circuit, you have a hot wire, a neutral wire, and often a ground wire. The hot wire carries the electrical current from the source to the load, the neutral wire provides the return path, and the ground wire serves as a safety measure to prevent electrical shock. Now let's examine 240-volt circuits. A 240-volt circuit, commonly used for appliances like electric dryers, ovens, and air conditioners, typically involves two hot wires, a neutral wire, and a ground wire. The two hot wires are each 120 volts relative to neutral, but 180 degrees out of phase, resulting in a 240-volt potential difference between them. This configuration allows for high power delivery compared to a standard 120-volt circuit. The role of a breaker is to protect the circuit from overcurrent conditions such as short circuits or overloads. When the current exceeds the breaker's rated amperage, the breaker trips, interrupting the flow of electricity and preventing damage to the wiring and connected equipment. Breakers are essential safety devices in any electrical system. So, why might a main breaker not be necessary in the context of a 240-volt receptacle? The key is the functionality of the receptacle itself. In some installations, the 240-volt receptacle may be directly wired to the electrical panel without an intervening main breaker. The circuit breaker protecting the individual 240-volt circuit then acts as the protection for that specific circuit. Secondly, it's important to understand the National Electrical Code, or NEC, requirements. The NEC provides comprehensive guidelines for electrical installations, including the types of breakers required for various circuits. It dictates the sizing of conductors, the type of overcurrent protection needed, and the proper installation methods. It is critical to consult the NEC for specific requirements related to 240-volt receptacles and breaker configurations. The NEC aims to ensure safety and prevent electrical hazards. Thirdly, consider the specific equipment being connected to the 240-volt receptacle. The design and power requirements of the equipment will influence the need for a main breaker. For example, a high-power appliance, like an electric vehicle charger, might necessitate a dedicated circuit with appropriate overcurrent protection. The manufacturer's specifications and the NEC guidelines should be followed to determine the appropriate breaker size and configuration. Factors influencing the decision to include a main breaker would be firstly, the electrical load. The total load connected to the 240-volt receptacle should be within the circuit's capacity. Secondly, the local electrical codes. Local codes might have additional requirements beyond the NEC. Thirdly, the panel capacity. The electrical panel should have sufficient capacity to handle the additional load. Fourthly, the wire size. The conductors should be appropriately sized for the current they will carry. Fifthly, the breaker size. The breaker should be sized to protect the conductors and equipment. Sixthly, the overcurrent protection. Proper overcurrent protection is essential to prevent electrical hazards. In summary, whether a main breaker is required for a 240-volt receptacle depends on several factors, including the specific installation, the NEC guidelines, and the type of equipment being connected. The statement that the receptacle itself acts as one of the contacts suggests a direct wiring configuration where the individual circuit breaker provides the necessary overcurrent protection. To determine the specific requirements for any electrical installation, it is always recommended to consult with a qualified electrician and refer to the latest edition of the National Electrical Code. Ignoring safety protocols can lead to severe electrical hazards. The grounding wire plays a critical role in electrical safety. It provides a low impedance path for fault current to flow back to the source, which helps to trip the circuit breaker and prevent electrical shock. Proper grounding is essential for all electrical circuits. Electrical panels should be properly labeled to indicate the circuits they control. This helps with troubleshooting and maintenance. Clear labeling can prevent accidental disconnection of critical circuits. Regularly inspect electrical panels and wiring for signs of damage or wear. Look for loose connections, corroded wires, and damaged insulation. Addressing these issues promptly can prevent more serious problems. Always disconnect power before working on electrical circuits. Use appropriate safety equipment, such as insulated tools and gloves. Following safe work practices is essential to prevent electrical shock. If you are not comfortable working with electricity, it is best to hire a qualified electrician. Electrical work can be dangerous, and it is important to have the necessary skills and knowledge to do the job safely. The purpose of electrical codes is to ensure safety and prevent electrical hazards. Compliance with these codes is essential for all electrical installations. Local authorities enforce electrical codes to protect the public. Understanding the NEC is crucial for anyone involved in electrical work. The NEC provides comprehensive guidelines for electrical installations. It covers a wide range of topics, including wiring methods, overcurrent protection, grounding, and equipment installation. The NEC is updated regularly to reflect new technologies and best practices. Staying up to date with the latest edition of the NEC is essential for compliance. Electrical inspections are conducted to ensure that electrical installations comply with the NEC and local codes. These inspections help to identify potential hazards and ensure that the electrical system is safe. Electrical inspectors are trained to identify code violations and ensure compliance. Passing an electrical inspection is essential for obtaining permits and ensuring the safety of the building. Electrical permits are required for many types of electrical work. These permits ensure that the work is done in compliance with the NEC and local codes. Obtaining the necessary permits is essential before starting any electrical work. Working without a permit can result in fines and delays. The NEC provides guidelines for the sizing of conductors. The size of the conductor must be appropriate for the amount of current it will carry. Undersized conductors can overheat and cause a fire. Properly sized conductors are essential for safety and reliability. The NEC also provides guidelines for overcurrent protection. Overcurrent protection devices, such as circuit breakers and fuses, are designed to protect electrical circuits from overloads and short circuits. These devices interrupt the flow of current when it exceeds the rated value. Proper overcurrent protection is essential for preventing electrical fires. The NEC specifies the types of wiring methods that are permitted for different applications. Wiring methods include conduit, cable, and raceway. The appropriate wiring method depends on the environment and the type of installation. Improper wiring methods can create electrical hazards. The NEC provides guidelines for grounding electrical systems. Grounding is essential for preventing electrical shock. A properly grounded system provides a lower impedance path for fault current to flow back to the source. This helps to trip the circuit breaker and prevent electrical shock. The NEC also provides guidelines for equipment installation. Equipment must be installed in accordance with the manufacturer's instructions and the NEC. Improperly installed equipment can create electrical hazards. The NEC covers a wide range of electrical equipment, including lighting fixtures, appliances, and motors. Understanding the NEC requirements for each type of equipment is essential for safe installation. The NEC is a complex document, but it is essential for anyone involved in electrical work. Taking the time to study and understand the NEC can help to prevent electrical hazards and ensure the safety of electrical installations. The main breaker's purpose is typically to disconnect all power to a panel in one action. In residential settings, it might be the utility feed breaker that shuts off all branch circuits fed from that panel. In commercial or industrial settings, the main breaker would disconnect all power from the panel to all the downstream loads it is feeding. The breaker sizes are chosen to protect conductors and equipment from overcurrent conditions. The breaker rating in amps needs to be suitable for the smallest wire size in its circuit per NEC table 310.15b16. The breaker protects the wire from overheating and causing a fire. In the case of the 240-volt receptacle, the existing breaker, the panel protects the circuit. Adding another main breaker, the receptacle itself, would be unusual and might not be necessary unless specifically required by local codes or the equipment manufacturer. It is always best to consult with a qualified electrician to ensure compliance with all applicable codes and regulations. They can assess the specific situation and determine the best course of action. If the 240-volt receptacle is for a specific piece of equipment, the equipment manufacturer's instructions should be followed carefully. These instructions may specify the type and size of breaker required. In addition to the NEC, local codes may have additional requirements. It is important to check with the local authorities to ensure compliance with all applicable codes. Electrical safety is paramount. Working with electricity can be dangerous, and it is important to take all necessary precautions. If you are not comfortable working with electricity, it is best to hire a qualified electrician. Electricity follows Ohm's law, which describes the relationship between voltage, current, and resistance. Understanding Ohm's law is essential for understanding electrical circuits. Voltage is the electrical potential difference between 2 points. It is measured in volts. Current is the flow of electrical charge. It is measured in amps. Resistance is the opposition to the flow of current. It is measured in ohms. Ohm's law states that voltage is equal to current times resistance, or volts equals amps x ohms. This simple equation can be used to calculate the voltage, current, or resistance in a circuit if the other two values are known. Power is the rate at which electrical energy is transferred. It is measured in watts. Power is equal to voltage times current, or watts equals volts x amps. Understanding power is essential for determining the size of breakers and conductors required for a circuit. Electrical circuits can be wired in series or parallel. In a series circuit, the components are connected end to end, so the current flows through each component in turn. In a parallel circuit, the components are connected side by side, so the current has multiple paths to flow through. The type of circuit used depends on the application. Series circuits are often used for lighting, while parallel circuits are often used for power distribution. Electrical panels are used to distribute electrical power throughout a building. The panel contains circuit breakers that protect the individual circuits. Electrical panels must be properly installed and maintained to ensure safety. Electrical panels should be inspected regularly for signs of damage or wear. Loose connections, corroded wires, and damaged insulation should be addressed promptly. Electrical panels should be labeled clearly to indicate the circuits they control. This helps with troubleshooting and maintenance. Electrical permits are required for many types of electrical work on electrical panels. These permits ensure that the work is done in compliance with the NEC and local codes. Working without a permit can result in fines and delays. The NEC provides guidelines for the installation and maintenance of electrical panels. Compliance with these guidelines is essential for safety. Electrical inspections are conducted to ensure that electrical panels comply with the NEC and local codes. These inspections help to identify potential hazards and ensure that the electrical system is safe. Electrical inspectors are trained to identify code violations and ensure compliance. Passing an electrical inspection is essential for obtaining permits and ensuring the safety of the building. Electrical work can be dangerous, and it is important to take all necessary precautions. Always disconnect power before working on electrical circuits. Use appropriate safety equipment, such as insulated tools and gloves. Following safe work practices is essential to prevent electrical shock. If you are not comfortable working with electricity, it is best to hire a qualified electrician.